All right, welcome back. Today we're going to tackle a really core piece of network security, access control lists, or as you'll usually hear them called, ACLs. So let's just dive right in. Think about it for a second. The internet is this, well, it's a wild, chaotic place with data just flying around everywhere. So how in the world does a private network, like at your office or even at home, stop all the wrong data packets from barging in and causing all sorts of trouble? Well, the answer is you hire a bouncer. A digital bouncer. And that, in a nutshell, is exactly what an access control list is. It's just a set of rules that stands guard at the door to your network, checking every single packet of data that tries to get in or out. It decides who's on the list, who gets past the digital velvet rope, and who gets turned away. Now, this bouncer doesn't just make things up as it goes. Oh no, it follows a very, very strict set of rules. And if you can understand these rules, you'll understand exactly how ACLs work. Okay, first up, top-down processing. The bouncer reads its list from the top down, and the very first rule that matches a packet is the one that gets applied. That's it. The process stops right there. So the order of your rules, it's absolutely critical. Second, the rules are directional. An ACL has to know if it's checking traffic coming in the door, which we call inbound, or traffic going out of the door, which is outbound. And third, and this is probably the most important rule of them all, is the implicit deny. Just imagine that at the very bottom of every single ACL, there's this invisible rule that says, deny everything else. Any packet that gets all the way to the bottom of the list without matching a specific permit rule gets blocked. Automatically, no exceptions. So just like in the real world, you wouldn't have the same bouncer for a local pub as you would for a high-security government building, right? Same deal with ACLs. There are two main categories you need to know: standard and extended. On one side, you have your standard ACLs. This is your generalist bouncer. It's a little bit of a blunt instrument because it only looks at one thing: where the traffic is coming from. That's the source IP address. It's simple, it's fast, but it's not very specific. On the other side, you've got extended ACLs. Now, this is your specialist. This is the bouncer in the suit with the earpiece. It's incredibly detailed. It checks where you're from, where you're going, the type of traffic like web or email, and even the specific door or port that it's trying to use. This gives you incredibly precise control over your network. And here's a pretty cool detail for you. For a long time, network engineers could tell these ACLs apart just by using number ranges. As you can see here, standard ACLs were typically numbered somewhere between 1 and 99, while extended ones lived in the 100 to 199 range. It's just a quick way to know if you're dealing with the simple bouncer or the specialist. At the end of the day, it's that classic trade-off between simplicity and precision. So our bouncer has its guest list, which is just the ACL rules, but how does it actually read the addresses on it? Well, it's not like a normal address book. It uses this special code called a wildcard mask. Now, this might seem a little tricky at first, but I promise you the logic is surprisingly simple once you see it. So a wildcard mask is nothing more than a filter. It's a series of numbers that tells the ACL which parts of an IP address to pay really close attention to and which parts it can just kind of ignore. Think of it like the bouncer taking a highlighter to the guest list and marking only the most important parts of each name. The first rule is dead simple. Wherever you see a 0 in the wildcard mask, the corresponding number in the IP address has to match the rule perfectly. The bouncer is being an absolute stickler here. There's no wiggle room. And the opposite is true for the ignore part. In the mask, if a whole section is a 1 in binary, which is 255 in decimal, you're telling the bouncer, hey, for this part of the address, I don't care what the number is. It can be anything at all. This is what makes the rule so flexible. Okay, let's put it all together, because this example makes it click. Let's say you have a rule for the IP address 192.168.1.0, and you give it the wildcard mask 0.0.0.255. What you're really telling the bouncer is this: the first three numbers have to be 192.168.1. Those zeros mean they must match. But that last part, the 255, I don't care what it is. And just like that, with one single rule, you've matched every single device on that network. That's pretty powerful stuff. Okay, we've gone through some of the technical details, but let's zoom back out for a minute. Why are we going through all of this trouble? Why do we even need these digital bouncers? It really all comes down to the impact they have in the real world. And there are three huge benefits. First and foremost is enhanced security. You can write rules that say things like, only the folks in the accounting department can talk to the financial server. And just like that, everyone else is blocked. Second is traffic flow control. You can manage your bandwidth by limiting traffic that isn't as important. And third is a big one: improved performance.
By blocking all that junk traffic right at the network's front door, you keep it from ever getting inside and slowing down your internal devices. Everything just runs a whole lot faster. So, from blocking unwanted guests to directing traffic, access control lists are kind of the silent guardians of our networks. They're the essential bouncers, keeping everything in order in all that digital chaos. And that leaves us with one final thought. Now that you know how the bouncer works, what's the first security rule that you would set for your network?